4. The Skeleton's Secret. What is dark matter? The substance that builds the cosmic web. Prologue. The web has the skeletons. The cosmic web is a network of mass. We can map its scaffold by lensing and motion. That is, material identity is unknown. In the case 5, it's a primary witness statement. This episode treats dark matter like a case 5, evidence, constraints, suspects, and tests that can fork a name. The method is always the same: isolate signal, destroy alternative, explanation, and demand replication. To make this reliable, teams cross-check with independent people, analyze prior and conservative assumption. If the conclusion surveys these trends, it graduates from interesting to robust. If it's collapsed, it's become a lesson in how the universe can imitate evidence. The key question for the next chapter is simple. What does this clue eliminate? And what does it leave alive? Because narrowing the answer is how science moves even before the final name is spoken. Chapter 1. Rotation Curve. The first alarm. Galaxy rotation curves refuse to follow the ways visible matter predicts. In the case 5, it's a primary witness statement. The discrepancy persists across galaxy types, implying the universal invisible component rather than a local accident. The uncomfortable truth is that modern cosmology is an inference machine. Dark matter is the strongest inference it produced. To make this reliable, teams cross-check with independent people, alternate priors, and conservative assumptions. If the conclusion surveys those changes, it graduates from interesting to robust. If it's collapsed, it's become a lesson in how the universe can imitate evidence. The key question for the next chapter is simple. What does this clue eliminate? And what does it leave alive? Because narrowing the answer is how science moves, even before the final name is spoken. Chapter 2. Clusters. When gravity outweighs light. Galaxy cluster demand far more mass than galaxies provide. In the case 5, it's a primary witness statement. Independent methods, dynamics, hot gas, and lensing agree that something unseen dominates the potential. Every constant is mapped, even research tightens the possible territories. To make it reliable, teams cross-check with independent people, alternate prior, and conservative assumption. If the conclusion survives those changes, it graduates from interesting to robust. If it's collapsed, it's become a lesson in how the universe can imitate evidence. The quick question in the next chapter is simple. What does its clue eliminate, and what does it leave alive? Because narrows its answer is how science moves, even before the final name is spoken. Chapter 3. The Parent Purged. Why hidden no more matter form? The early universe fixed baryon density. You can hide baryon, but you can invent extra one without breaking cosmic chemistry. In the case 5, it's a primary witness statement. So, the missing mass must be non-baryonic. Investigator, G is not as a myth, but as a measurable hypothesis with clear failure mode. Chapter 4. The CMB. Dark Matter in the Baby Universe. Acoustic peaks in the CMB encode the matter mixture and require a non-baryonic component present before galaxies exist. In the case 5 is a primary weakness statement. Dark matter is written into the early universe, not patched to the later. Investigator did is not admit, but at a measurable hypothesis with clear failure mode. Chapter 5 Lensing Mass confessed through curvature. Lensing map revealed mass when light is quick and measure total mass regardless of emissions. In the case 5, is the primary weakness statement. If light can lie in omission, lensing cannot. Its response to wet. The tension comes from scale. The signal is cosmic, but the text may be microscopic, or vice versa. Chapter 6 Merging cluster mass separate from gases. In high-speed collision, cool gas large but landing mass tracks the collisionist component more closely. In the case 5, is a primary weakness statement. This behavior constrains how strongly dark matter can cell interact. Investigator treats this not as a myth, but as a measurable hypothesis with clear failure mode. Chapter 7 What dark matter is not antimatter, not dark energy, not simply dim stars. In the case 5 is a primary weakness statement. Dark matter is a gravitating component that clusters and shapes structural growth. The method is always same: isolate signal, destroy alternative explanations, and revenge replication. Chapter 8 The Space Port WIMPs Ancients, Stereos, Neutrons, Primordial Black Holes, Hidden sectors, and Modified Gravity are the major suspects. In the case 5, is a primary weakness statement. It predicts different interaction and different small-scale structural texture. The tension comes from a scale. The signal is cosmic, but the text may microscopic or virtual. Chapter 9 Thermal History Hot, warm, cold. Cold dark matter means slow moving a structure formation time, enabling small halos and filament graininess. In the case 5, it is the primary weakness statement. Warm or hot candidate smear small structure. The wet becomes smoother. Investigators treat it not as a myth, but as a measurable hypothesis with clear failure mode. Chapter 10 WIMPs The Classic Candidate. WIMPs were attractive due to WIMP micro relic abundant logic. In the case 5, is the primary weakness statement. Note result have present simple model, but not eliminate all possibilities. The tension comes from scale. The signal is cosmic, but the text may be microscopic, or vice versa. Chapter 11 Direct Detection Underworld Templates. Detectors want for real nuclear recall in ultra-quiet environment. In the case 5, it is a primary weakness statement. The challenge is background discrimination at vanishing rate. The uncomfortable truth that modern cosmology is an inference machine. Dark matter is stronger inference is produced. Chapter 12 The Neutral Flaw. Neutral become a irreducible background that mimics low-rate dark matter scattering. In the case 5, its primary weakness statement. Directional detections and multi-target strategies become essential. Investigator treat is not admitted, but as a measurable hypothesis with clear failure mode. Chapter 13. Indirect detection, sky-based forensics. Annihilation or decay could produce gamma rays or other messages. In the case 5, it is a primary witness statement. Astrophysical confusion demands conservative clarm and cross-check. Investigators treat it not as a myth, but as a measurable hypothesis with clear future mode. To make it reliable, teams cross-check with independent people like alternate prior and conservative assumptions. If the conclusion survives those challenges, it graduates from interesting to robust. If it's collapsed, it's become a lesson in how the universe can imitate evidence. The key question in the next chapter is simple. What does the clue eliminate, and what does it leave alive? Because narrowing the answer is how science moves, even before the final name is spoken. Chapter 14. Collider. Missing energy signatures. Collider search for events with momentum impellence consistent with invisible particles. In the case Y, is a primary weakness statement. Some dark matter candidates may be beyond collider, rich or too weakly coupled. Every constant in the map it. Every new research tightens the possible territory. To make it reliable, teams cross-check with independent people like attended prior and conservative assumptions. If the conclusion survives those chains, it graduates from interesting to robust. If it's collapsed, it becomes a lesson in how the universe can imitate evidence. The key question is the next chapter is simple. What does the clue eliminate, and what does it speak alive? Because narrowing the answer is how science moves, even before the final name is spoken. Chapter 15. Ancient. Dark matter at the coherent field. Ancients can behave like a field, researched via conservation. The two photons in a strong magnetic field indicated as a primary weakness statement. They remain viable cross-band parameter space. Every constant is a map it. Every research tightens the possible territory. To make it reliable, team cross-check with independent people like underneath prior and conservative assumption. If the conclusion surveys those chains, it graduates from interesting to robust. If it's collapsed, it becomes a lesson in how the universe can imitate evidence. The key question for the next chapter is simple. What does the clue eliminate, and what does it leave alive? Because narrowing the answer is how science moves, even before the final name is spoken. Chapter 16. Stellar neutrinos and warm dark matter. Warm candidates suppress small-scale structure and are constant by high redshift structure measurement. In the case 5, as a primary weakness statement. They can't erase more than the universe allows. Investigators treat it not as a myth, but as a measurable hypothesis with clear failure mode. To make it reliable, teams cross-check with independent people like alternate prior and conservative assumption. If their conclusion survives those chains, it graduates from interesting to robust. If it's collapsed, it becomes a lesson in how the universe can imitate evidence. The key question for the next chapter is simple. What does this clue eliminate, and what does it leave alive? Because narrowing the answer is how science moves, even before the final name is spoken. Chapter 17. Primordial black holes. BB is are dark and massive, but constrained by microlensing, CMB effects, and structure formation. In the case 5, is a primary weakness statement. There may be a particle contributors in limited mass window. The uncomfortable truth is that modern cosmology is an inference machine. Dark matter is the strongest preference it produced. To make it reliable, teams cross-check with independent people like Antoinette Brewer and conservative assumptions. If the conclusion survives those chains, it graduates from interesting to robust. If it's collapsed, it's become a lesson in how the universe can imitate evidence. The key question for the next chapter is simple. What does the clue eliminate, and what does it leave behind? Because narrowing the answer is how science moves, even before the final name is spoken. Chapter 18. Cell-interacting dark matter. Cell interactions can create quarks and grow halos, potentially addressing some small-scale issue. In case 5 is a primary weakness statement. Clusters still constant keep the interaction trends in the shadow corridors. Investigators chase not at a myth, but at a measurable hypothesis with clear failure mode. Chapter 19. Your trained fuzzy dark matter. Wave-like behavior suppresses broad structure below at the molecular scale, smoothing halos and filaments. In the case 5, it is a primary weakness statement. The web is smallest gain before it comes the measuring tape. The tension comes to the scale. The signal is cosmic, but the text may be microscopic or vice versa. Chapter 20. Modify gravity, the high bar. Any gravity modifications must reproduce the CMB and growth history simultaneously. In the case 5, is a primary weakness statement. Many models reintroduce traditional fields that behave dark matter like every constant is a map eq. Every new result tightens the possible territory. Chapter 21. The small-scale crime scene. Thrust, cord or cups, and satellite caused test microphysics, but variants complicate interpretation. In the case 5, is a primary weakness statement. The goal is to find signatures that survey baryonic uncertainty. Investigators treat it not as a myth, but as a measurable hypothesis with clear failure modes. Chapter 22. The Lyman Unfair Forest. Absorption in quasi-spectral probe. Small-scale structure in high pressure. In the case 5, is a primary weakness statement. It contains warm and unstrained light model, with the measuring powerful spectrum cutoffs. The tension comes from scale. The signal is cosmic, but the test may be microscopic or vice versa. Chapter 23. The web's other detector. Filament thickness, connectivity, the substructure statistics in court, the matter powerful spectrum. In case 5, is a primary weakness statement. Let's survey turn cosmic volume into a laboratory. Investigators see it not as a myth, but as a measurable hypothesis with clear failure mode. Chapter 24. Hollow strip, hollow triosity, and sphericity, constant collision lateness, and cell interaction. In the case 5, is a primary weakness statement. Lensing and dynamics provide preliminary shape information. The uncomfortable truth is that the modern cosmology is an inference machine. Dark matter is the strongest inference it produces. Chapter 25. Dark matter weather. Local stream and substructure could affect detector signal and angular modulation. In the case 5, is a primary weakness statement. A true modulation should replicate across experiments with different systematics. The tension comes from scale. The signal is cosmic, but the test may be microscopic or vice versa. Chapter 26 Cosmic Door and First Light. The timing of first galaxy depends on spore highly abundant, which depends on dark matter microphysics. In the case 5 is a primary weakness statement. Early universe observations become indirect particular constant. Investigating treat is not admitted, but as a measurable hypothesis with clear failure mode. Chapter 27 The Evidence Triangle. Cosmology, physics abundance and clustering. Astrophysics tests Halo behavior. Particle physics reserved for coupling. In the case Y, in the primary weakness statement, a real solution must sit in an intersection. The tension comes from scale. The signer is cosmic, but the test may be microscopic or vice versa. Chapter 28 Why discovery can be slow. The dark setting may be complex, multiple states of hidden interaction. In the case Y, is a primary weakness statement. Progress may look like narrowing is constant rather than a single dramatic event. The tension comes from scale. The signal is cosmic, but the test may be microscopic or vice versa. Chapter 29 What a smoking gun would look like. A confirmed signal across independent targets and methods would transform the case file into identity. In the case file is a primary weakness statement. The strongest claim make new predictions and survey hostile tests. Every constant in the maps each. Every new result tightens the possible territory. Chapter 30 Next Gen Observation Theory. Future surveys cover small-scale power measurement and lensing tomography. In the case file is primary weakness statement. They can detect cutoffs, smoothing scales, and subro-halo property stripped. Investigators treat this as not a myth, but as a measurable hypothesis with clear failure mode. Chapter 31 The Final Courtroom. WIMP's constant. ASEAN port. One bonded by structure. BBS patrol. Cell interaction nodal. Modified gravity high bar. In the case 5 is primary weakness statement. The subject leads it is shrinking. It is that a process. The uncomfortable truth is that modern cosmology is an inference machine. Dark matter is the strongest inference is produced. Chapter 32 Why it changes every story in the sky. Dark matter sets the scaffolding for galaxy formation and cosmic web architecture. In the case 5 is a primary weakness statement. Naming it rewrites the origin story in every luminous object. Investigator treat is not a myth, but as a measurable hypothesis with clear failure mode. Chapter 33 Philosophical Landing. We live in the baryonic islands in the dark skeleton. In the case 5 is a primary weakness statement. Reality is not obligated to sign. The deepest structures can remain visible. The density comes from scale. The signal is cosmic, but the test may be microscopic or vice versa. Epilogue. The skeleton could have a name. We already mapped dark matter by its gravitational handwriting. In K5 is a primary weakness statement. Identity will likely come from the convergence. Laboratory hints Pluto's cosmic structure, constraint locking into one coherent explanation. The uncomfortable fact is that modern cosmology is an inference machine. Dark matter is the strongest inference is produced. Chapter 34 Parameter Space. Why dark matter lives on chart. This chapter exists because dark matter is not solved by one measurement, but by a web of constraints. Its constraint is a world that forces candidates into narrower conditions. In the case 5, is the motive and the matter in one frame. When viewers hear no detection, they hear failure. In science, new results are cartography. They turn a story into a pointed map where only certain reasons remain possible. The technique looks boring on paper and thrilling in consequence. It destroys easy stories and leaves only hard truth. The word here is not added mystery for mystery's sake, is to show how modern cosmology survived its own ambition to design tests that can prove it wrong. The constant from sky and lab agree. Parameter space collapsed like a net tightening around subject. Operationally, teams translate it into measurable output, likelihood, posterior, and exclusion cultures. These cultures are not decoration, they are the border of what reality still allows. The most dangerous trap is correlation, shaped assumptions across people like that produce the same wrong answer. So the community value independence, different instrument, different reduction, different prior. If the card survives the chapter constant, it becomes more plausible, not because it's exciting, but because it's harder to skill. And the harder a hypothesis is to kill, the closer it's going to be to truth. Hold that thought, because the next chapter tightens the constant again. Still, the subject leads start to look less like a list and more like a short layup. Chapter 35. The Large Scale Assumption. By chapter 35, the investigator reaches the large scale assumption we are allowed to keep. Whatever dark matter is, it behaves gravitationally like a cold board component on lit scale, because otherwise the cosmic web would not look the way it's there. But cold in a lit scale is not the identity, it is only a boundary condition. Now we turn the case inside out. Instead of asking, which candidate do we like? We ask which signature or fourth nature to reveal what it is, no matter what we want to believe. That should matter because the good mystery doesn't end when we pick a favorite subject, is when the subject can no longer hide behind ambiguity. So from here forward, the episode becomes a sequence of track shifting measurements decided to the different dark matter families contradict each other. Chapter 36. The inversion. Stop trading particular. Start trading scale. The particular can hide, a scale cannot. Dark matter candidates differ more sharply in where they spread in structure. The characteristic length and mass scales below which the universe stops making small halos. That turnover is the closest thing we have to the fingerprint that doesn't depend on laboratories. So, the strategy becomes measure the smallest structure in universe permits in multiple independent ways until the allowed scale range becomes narrow. It became measure that cut-off scales precisely. You don't need to guess whether dark matter is warm like cell interacting, or something else. Many options will seemingly become incompatible with the same number. The story stops being a debate and becomes a measurement campaign. Chapter 37. The most important data product you've never seen. It is a plot that quietly controls the world's conversation. The small-scale matter power spectrum. Think of it as a map of a clumpiness Venus scale. On this scale, the spectrum is well measured. The mystery is what happens on a small scale with different microphysics like a curved band, flattened or cut off. The difficulty is that we cannot see dark matter directly, so we measure the power spectrum indirectly using different travel, lensing shear statistics, Galaxies structure with biased modeling, high rates of absorption, satellite populations, and substructure effects. Each treasure had its own systematic, but its multiple traits converge on the same small-scale behavior. Thus, conversions become extremely hard to fake. It is the quiet heart of the investigation. Their identity is not a science detection, it occurs becoming incompatible with certain models. Chapter 38 Strong lensing anomalized at a visible object cost. Strong lens is not only predict art, there is precision instrument. When the distant cluster is landed into multiple images, the blindness ratios and micro perturbations carry information about small clusters in the lens galaxy halo, clusters in that may contain no stars and emit no light. That is key advantage. Lensing anomalized count substructure without requiring it to be luminous, but is also trapped. Lens modeling degeneracies can mimic subtraction. Short structure can complicate flood radial. Microlensing by stars can add noise, so teams escalate to more robust observable multi-wavelength flood radicals, time-delayed perturbations, and population statistics across many lands. If the subtraction abilities infer from lensing is high, if flavor codes and clumpy families, it is consistently low across well-moderated sample. Warm and white light family can grow. The sky becomes a sensor taker. Chapter 39 Time Delays Gravity with a Stopwatch. Now we bring in a tool that feels almost unfair time. In a gravitational lens, light takes multiple roads. The roads have different lengths and pass through different gravitational potential, so they arrive at different times. That delay is a clock written into space-time. Small hollow clumps can perturb the delay pattern in a measurable ways. The matters because delays the less vulnerable to certain brightness-related systematic. When you compare stable time delays, lens model constrained by high-resolution imaging, and repeated monitoring of lens transit, you can isolate the contribution of small-scale structure with unusual precision. It is one of the sharpest chart design in the entire case file. If you can measure substructure storing timing, you can front model to either predict enough clumps to match or a midday process them. Chapter 14 Stellar Streams The Milky Way Silent Detection Drill. If lens count clumps in other galaxies, streams count clumps in ours. The stellar stream is a narrow ribbon of stars, thin enough that a passing subhalo leave an imprint, gaps, density variations, and phase space distortion. You don't need the subhalo to grow. You only need it to pass close enough to disturb the stream. The strength of streams is also their weakness. Baryonic structures can mimic some effects. Giant molecular closed spiral arms and the disk is there that can perturb stream. So the Q tests are specific. There's a scar distribution marked by bionic perturbed line. Those are perturbations, so the characteristics symmetries invested from the flyby to multiple streams at different radi and orientation tell the consistent story. When stream evidence is compiled across many systems, it becomes a statistical subhalo sensors and a sensor narrows identities. Chapter 41 The disk track. Skill and why is part of the truth. Even if matter is clumpy in the principle, clumps can be destroyed. Near the galaxy disk, tidal fault, repeated crossings, and stellar encounters can disrupt small subhalos. It means like detected clumps in the inner halo does not automatically mean the microphysics specs the clumps. It may mean the environment kills them. It's important because it's where many arguments fall. People assume no clumps scenes imply clumps don't exist. In reality, the correct inference is conditional. Clumps might exist in late ruddy, survive better in the quiet environment, and still be consistent with core microphysics. So, the investigation must separate formation from survival. Is how the case becomes sophisticated. Identity is inferred from what survives across environments, not from one reason's silence. Chapter 42 High Redshift Weakness Before Galaxies Got Messy. If radiance complicate the present, go to the past. High redshift prober, especially absorption-based structural measurements, test small-scale power before feedback, star formation, and disk shock could rewrite the evidence. It is why early universe constraints are powerful. They interrogate microphysics in a regime where astrophysical complexity is lower. When an early universe observable limits how much small scale structure could have been erased, it directly fenced worm-like and quake-like candidates into narrower corners. It is one of the exposure's key escalation bits. The evidence becomes time-separate. The model must work both before and after galaxies complicate the story. Chapter 43 Cosmic Door First Light at the Timing Experiment. Now we do a parental logic. The first stars needed small halos. If dark matter spread small-scale structure too strongly, the earliest star formation shapes later, and the timeline of a re-energization chains that can be tested indirectly through early galaxy count and global history. The dramatic forming is simple. If dark matter smooths too much, the universe turns its light onto light. So, early cosmic history becomes a stopwatch for microphysics. You don't need to talk the possible. You need to show that its suppression would have prevented the universe from becoming luminous when it did. Chapter 44 The Lab's Return Why neutrino still matters. Now we return to Earth, but with a changed mindset. Laboratory experiments are not failing to find dark matter. They are mapping interaction space. Each new result pushes visible candidate toward either weaker coupling, different coupling channel, or a different mass range. The important point is integration. Astrophysics tells dark matter is there. The lab tells how the light is taught to normal matter. If the lab science continues while astrophysical constraint tightens, one corridor becomes more plausible. Dark matter may be nearly gravitational only, or it may copper through channels, and we are not listening for it correctly. It's not defect, it's guidance. Chapter 45 The neutral wall when background becomes the story. At extreme sensitivity, an experiment can be so good that nature itself becomes a dominant background. Neutrinos can mimic low-rate scattering signatures. It's for direct detection designed to evolve directionality, multi-material confirmation, and careful spectral discrimination. In a documentary, it's a perfect hard mode moment. The visible is hiding behind another visible. But scientifically, it's also an opportunity. If you can pit the neutral background with a directionality, you gain a signature that is extremely hard to fake. The investigation becomes less about raw sensitivity and more about clever discrimination. Chapter 46. The Dark Session. If the answer is not one thing. Now, we allow to control the expansion without turning into fantastic. Dark matter might not be a single particle species. It could be a shatter, multiple components, cell interactions, or dark radiation, still constrained by cosmology, but richer than the single WIMP-like picture. This mattered because it changes expectations. If the dark session is complex, the identity may not arrive as one dramatic discovery. It may arrive as a consistent explanation that unflied the many small highs. The key rule remains: complexity must be predictive. If a model can fit anything, it explains nothing. So, the case file accepts dark sector richness only when it reduces ambiguity across datasets. Chapter 47. The Discovery Standard. What would convince everyone? At this point, it had to state the standard explicitly, because it said how the story ends. The community-level dark matter identity claim would require independent replication, cross-method confirmation, and a signature that survives hostile alternative model. Example: a direct detection signal confirmed across different target materials with a consistent scaling loss. A substance structure sentenced consistent across lengths, streams, and high redshift constant. A measured cutoff scale matching one's microphysics class and contradicting other. It isn't a moving goalpost. It's the only way to prevent premature identity assignment in an over-constrained universe. Chapter 48. The final map. Make three independent methods agree. Here is the best trap we can set for nature. 1. Measure a substructure of buildings with strong lensing statistics. 2. Measure Haller's perturbation rate with stellar stream scars. 3. Measure early small-scale power with high absorption constant. Then ask one question: can the same microphysics satisfy all three simultaneously with a same cutoff scale? If yes, identity corridors shrink dramatically. If no, something about our assumption is wrong, either in modeling, systematic, or physics. It's where the mystery stops being cinematic and becomes inevitable. Chapter 49. What is the best ending looks like? The best ending is not, we found it in a detector tomorrow. The best ending is, the corridor becomes too narrow to ignore. Because even without a single laboratory event, the universe can form an identity class, cold and clumpy within certain powers, weak light within a constant mass window, warm only within narrow suppression, cell interaction only within a specific cross-section corridor. That outcome is a triumph. It means we learned the nature of the fundamental component for the architecture it built. In science, that is as real as a particle in a jar. Chapter 15. Epilogue. The skeleton secrets won't stay secret. Dark matter had already revealed itself as web and architecture. The remaining secret is the labor we attach to its behavior. And secrets in physics not last forever when the universe provides repeated structure, measurement technology keeps scaling, and independent proof convert. The identity will not be hand to earth with drama. It will be fraught with a constraint until every alternative breaks something else. And when that happens, the cosmic web will still look the same, but we will finally know what it's made of. Chapter 51. The short-lived is not a list, it is a corridor. By this point, the investigation has done something viewers rarely seen in a documentaries. It has revealed a suspect lead with a corridor of allowed behavior. That corridor has shaped. It had a boundary. It narrowed when the new datasets arrive, and it narrows more aggressively when the new dataset is truly independent, built from a different instrument class and different physics remind, or a different epoch in a cosmic history. This is important because most popular explanations treat dark matter identity like a popularity contest. It is not. It is an optimization under constraints. A candidate wins when it can fit all the data without inventing free parameters that would break the next dataset. So the short list isn't a list of names, it's a list of robotized still permitted. How small structure can get, how fast it formed, how it behaves in dense conditions, how it shapes hollow interior, how it covers or doesn't to ordinary matter. Now, we put the corridor toward the corner. We ask the measurements can collapse it further in the next 3 to 5 years. Chapter 52. The most important shift, population beat anecdote. One event can be mismodeled. One galaxy can be warped. One lens can be the messy shot. One stream can be hit by a baryonic perturber. One detector run can have unrecognized background structure. Population statistics are the antidote. When you move from a single case to telling a population inference, you turn the problem into something nature cannot perform on demand. You stop asking, is one object evidence, and start asking, is distribution consistent with the microphysics? That's where the identity problems become solvable, because different dark matter families do not merely predict different outcomes for one object. They predict different distributions. The number of subhollows as a function of mass,